Another day, another learning. Hello and welcome to our channel, English Listening Practice with Hot Science News. This channel will be helpful in improving English listening for students and scientists who are not English native speakers. You will listen this science article in female or male voice for better listening practice. At the end of the original article, the summary for laymen is following. Listening practice with female voice first. Today's original article is prepared by Bethany Berkshire PhD, and published in Science News on March 31, 2023. Title: A new battery starves cancer cells of oxygen in mice. It's not great when a person sucks all the oxygen out of a room. When a battery does it to a tumor, though, it could be a good thing. A tiny self-charging battery wrapped around a tumor removes oxygen from the cancer cell's environment, boosting the power of some cancer therapies, a study in mice shows. Mice that had small batteries wrapped around their breast cancer tumors, combined with cancer therapy, showed a 90% decrease in tumor volume in 2 weeks, researchers report March 31 in Science Advances. Solid tumors, such as those that can develop in breast cancer, often grow rapidly, so rapidly that the tumor's growth is faster than its blood supply can support. This means that the center of many tumors can be hypoxic, with much lower oxygen levels than surrounding tissue. Hypoxia is a double-edged sword, says materials scientist Yang Yaoxia, who specializes in battery materials at Fudan University in Shanghai. Low oxygen levels in tumors mean that the body's immune cells often cannot survive long enough to kill the cancerous cells. Hypoxic cells are also resistant to treatments like radiotherapy and even to traditional chemotherapies, as there isn't enough blood flow to deliver a deadly dose, explains Fudan's Fan Zhang, who studies biomedical materials. On the other hand, it provides a target for precision treatment of tumors, Xia and Zhang write in the new paper. The hypoxia could act as a beacon for chemicals called hypoxia-activated prodrugs. These are chemotherapeutic drugs hooked to a linking chemical that ensures the drug becomes active only in a low-oxygen environment, says Qing Zhang, a molecular biologist at the University of Texas Southwestern Medical Center in Dallas, who was not involved in the study. But hypoxia-activated prodrugs don't show much benefit in clinical trials, possibly in part because the solid tumors they are deployed against are not evenly hypoxic or not hypoxic enough. Xia and Fan Zhang wanted to find a way to make tumors more hypoxic, to give the prodrugs a better chance. So the researchers and their colleagues deployed a tiny, flexible battery that could partially wrap around a tumor. The battery's zinc electrode self-charges by sucking up oxygen from the environment. It also creates highly reactive oxygen pairs that can damage DNA but aren't a usable form of oxygen for cells. By slurping up most of the available oxygen and producing lots of reactive oxygen pairs, the battery alone was capable of shrinking tumors in mice by up to 26% of their original size 2 weeks after implantation. When combined with a hypoxia-activated prodrug, average tumor size shrank by 90%. I think the concept, the scientific basis, is solid, Qing Zhang says. The findings are encouraging, he says, but extremely preliminary. Not only were the batteries deployed only in mice, but they also were used against a mouse-specific breast cancer. It has to be tested in several breast cancer models, and also has to be tested in other cancer models, he says. And, of course, in humans. And a 90% decrease in tumor size is not a 100% decrease. There's still 10% left, Qing Zhang says. If those cells survive, it could mean they are resistant to the hypoxia, and the tumor could grow back. As with many treatments, he says, it will probably have to be combined with other therapies to make sure the whole tumor is zapped for good. Xia, Fan Zhang and their colleagues are already thinking about how the battery might have to be made more flexible and more powerful to work on human-sized tumors, using battery energy to starve cancer of air. Summary for laymen. Scientists have discovered that solid tumors, such as those found in breast cancer, grow so rapidly that the tumor's growth exceeds its blood supply, resulting in low oxygen levels, called hypoxia, in the center of the tumor. Unfortunately, this hypoxic environment makes it difficult for the body's immune system to kill cancerous cells, and the hypoxic cells can be resistant to traditional cancer therapies. However, researchers have found that chemicals called hypoxia-activated prodrugs can target these hypoxic cells. The problem is that these drugs aren't very effective in clinical trials because the tumors aren't always hypoxic enough. To make tumors more hypoxic, researchers have developed a tiny battery that wraps around the tumor and removes oxygen from the cancer cell's environment. The battery also produces reactive oxygen pairs that can damage DNA. When the battery was combined with hypoxia-activated prodrugs, the tumor size in mice decreased by 90% in just 2 weeks. However, the researchers caution that the study is preliminary and was only conducted on mice with a specific type of breast cancer. They also noted that 10% of the tumor remained, which may indicate resistance to hypoxia. Despite these limitations, the researchers are excited about the potential of the battery and are already working to make it more flexible and powerful to work on human-sized tumors. Thank you for listening, and we hope you found this video helpful for improving your science English. Thanks for watching. Channel for non-native English speakers.